All right, so get this. A rat, a pigeon, and an AI walk into a cage. Now, it sounds like the beginning of a really weird joke, right? But what connects all three of them is the answer to a huge question. What's the real difference between smart, useful learning and just making silly, random connections? That's exactly what we're going to unpack. And we'll start with a bit of a riddle. What can a superstitious pigeon possibly teach a supercomputer? It seems a little ridiculous, but the answer, believe it or not, reveals a fundamental secret behind all machine learning, one that's just as true for an animal's brain as it is for the most powerful AI we can build. So let's start our story with a rat. It's got a classic life or death problem, figuring out what's safe to eat out there in the world. This is the ultimate test of learning from experience, where getting it right means you live and getting it wrong, well, you don't. Here's how the rat plays it smart. It finds some new food and takes just a tiny, cautious bite. A few hours later, it starts to feel sick. Right away, its brain forges a powerful link. That new taste equals feeling awful. But the real genius isn't just making that connection. The truly crucial part is what the rat does next. See, the rat doesn't just learn to avoid that one specific berry it ate. No, that would be too simple. Instead, it takes that one bad experience and creates a broad rule from it. It learns to avoid all foods that look and smell similar, even if it's never seen them before. This leap from a single data point to a general rule is called generalization, and it is the absolute hallmark of smart learning. Think about the difference here. Memorization is just remembering one fact. It's rigid. Generalization, on the other hand, is flexible. It's about predicting the future. And that's exactly what we want from our technology, right? Your email spam filter would be totally useless if it only memorized old spam. It has to generalize from those examples to spot the new junk that comes in every single day. But, learning doesn't always go so well. Now let's pivot to a really famous experiment by the psychologist B.F. Skinner, which shows us a completely different side of the coin, how this whole learning thing can go completely off the rails. So Skinner puts some hungry pigeons into a cage. A machine is set up to drop a food pellet in at regular intervals, say once every minute. Now the key detail here, the most important part, is that the food delivery has absolutely nothing to do with what the pigeon is doing. It's totally random, but of course the pigeon doesn't know that. So you can picture it. A pigeon is just kind of hanging out in its cage. At one particular moment, it just happens to turn its head to the left. And bam! At that exact same random moment, the feeder clicks and a food pellet drops down. Now, from the pigeon's point of view, that is not a coincidence. That looks an awful lot like cause and effect. And just like that, a superstition is born. The bird thinks, hey, I turned my head and I got food. I should do that again. So it keeps turning its head, and since the food keeps arriving on that same fixed schedule, the pigeon's useless little ritual gets reinforced over and over. It has learned a pattern that is completely false. Okay, so this gets us back to our big question. What is going on here? Why does the rat learn a brilliant, life-saving rule about the world while the pigeon learns a completely pointless dance? I mean, they're both learning from experience, right? They're both connecting an action to an outcome. What is the key difference? The secret, as it turns out, is a fascinating concept called inductive bias. The rat, you see, isn't starting from scratch. It comes into the world with some built-in knowledge, or at the very least, some very powerful assumptions about how things are supposed to work. And this chart just lays it out perfectly. The rat connects two things that are logically, biologically related: taste and sickness. The pigeon, though, it has no filter. It's totally happy to connect any two random things that just happen to occur close together in time. And this is where it gets really, really cool. Researchers actually tested this. They found a rat can easily learn to connect a taste with feeling sick later. But if you try to pair that same taste with something like an electric shock, the rat learns nothing. It doesn't avoid the food. Or if you pair a sound with making the rat feel sick, again, nothing. It's as if its brain is hardwired with a fundamental rule. Only things I eat can make my stomach sick. This pre-wiring, this is what we call its inductive bias. It's basically a set of starting assumptions that guide the learning process. It tells the brain which patterns are probably meaningful and which ones are probably just noise. And it's not a flaw. It's an incredibly useful feature that saves the rat from becoming a superstitious mess, like our poor pigeon.
So why on earth are we talking about rats and pigeons? What does any of this have to do with AI? Well, it turns out it has everything to do with AI. Because if we want to build machines that can learn useful things about our world, we have to give them the right kind of bias, just like the rat.
We use machine learning when we're dealing with problems that are just way too complicated to solve by writing down a list of rules. I mean, think about driving a car. You could never possibly write a program that covers every single thing that could happen on the road. It's impossible. So instead, we build systems that can learn and generalize from watching millions of hours of good driving.
We also need machine learning for systems that have to constantly adapt. Spammers, for example, are always coming up with new tricks. Your spam filter can't be static. It has to learn and evolve. A system with the right inductive bias can pick up on these new patterns quickly, without getting fooled by random, superstitious correlations.
And that brings us to the most important takeaway of all. The success of any AI, just like the survival of that rat, depends almost entirely on giving it the right set of starting assumptions. The big challenge in AI today isn't to build a system with no bias at all. A system with no bias would just be a superstitious pigeon, finding patterns everywhere. The real, difficult, and fascinating goal is to figure out what the right biases are for the job, and build those in from the very beginning.